Hello Year 9. We are going to be starting a new module which is called Tectonic Hazards, and in this module we're going to be learning about which parts of the Earth are affected by earthquakes and volcanoes and why that is. That's today's lesson. We're also going to be learning about what are the different hazards at different types of plate boundaries. Next we're going to be looking at why people choose to live in tectonic areas, what are the reasons for that. What are the effects of tectonic hazards on people and the places that they live is going to be the lesson after that. And then we're going to be examining how we can protect ourselves, or how people who live in areas that have tectonic hazards can protect themselves from tectonic hazards like volcanoes and earthquakes. And we're also going to be looking at some places that have suffered earthquakes recently to see how people living there have coped. And the places we'll be looking at are Nepal and also Chile. Okay, today's lesson then. Which parts of the Earth are affected by earthquakes and volcanoes, and why? First we need to recap the structure of the Earth, and you learnt about this in Year 8, so a lot of this is going to sound familiar, which is good. The Earth is made up of several different layers, and the top, outermost layer is called the crust, and it's between 50 and 100 kilometres thick. In comparison to the other layers, it's like the skin on an apple. It's really thin. Now you wouldn't think it at the surface on the crust, where everything seems pretty stable and the temperature's pretty cool, but at the centre of the Earth there is a raging inferno, and the deeper into the Earth that you go, the hotter it gets. So just underneath the crust is the mantle, and this is the thickest layer of the Earth, and it's 3,000 kilometres thick. It's made of molten rock, which is flowing slowly beneath the Earth's crust. So it's flowing almost like hot toffee. And we're going to come back to this. I'm going to explain why that is and how that works. As you get closer to the centre of the Earth, the heat and the pressure really build up, so that when you reach the Earth's core, which is made of heavy metals like nickel and iron, the temperature is 6,000 degrees Celsius. Now that is the same temperature as the surface of the sun. Because of that temperature, because there's all of that energy at the core, all of that energy wants to escape. It's a bit like steam inside of a boiling kettle. It's pushing outwards, putting immense pressure on the mantle, which in turn puts immense pressure on the crust, which is broken into pieces. And each piece is a different size and a different thickness. And we call those different pieces plates, and they're resting on top of the hot mantle, which if you could break them apart would look like this. Now these plates are being dragged around by forces deep within the planet. Think of it like a pot of boiling soup. So the Earth's core is the burner at the bottom, and the mantle is the boiling soup on top. And as the soup near the burner heats up, it gets less dense and it rises. But as it gets close to the surface, it cools off and sinks. And in physics, these are called convection currents. A similar process is driving the mantle, and it pulls the plates along with it. This movement of the plates by convection currents in the mantle, that's called plate tectonics. And this is the engine which is driving the constant transformation of our planet's surface. Now, plates have been moving around on the surface like this for millions and millions and millions of years. The oceans have expanded, land masses have smashed into each other where they meet at plate margins, forming mountains, volcanoes, and causing earthquakes. And this shows where all of the Earth's tectonic plates are, and the red lines are showing the plate margins, so that's where the plates meet. The arrows, the blue arrows, they're showing how the plates are moving and the direction the plates are moving. So the plates, they move in relation to each other due to the convection currents in the mantle. Okay, at constructive plate margins, so they're just the straight red lines with no triangles on them or lines. I've marked that on the key. At constructive plate margins, the plates are moving apart. And as they move apart, a gap is formed and they leave a gap behind them, and that's filled by magma rising from the mantle, rising to the surface, and that forms a new crust. At destructive plate margins, which are the lines that have got the red triangles on them, at destructive plate margins, plates are moving towards each other, and one plate will be pushed under the other plate, melting as it gets forced into the hot mantle which is underneath the crust. You'll come back and study this in more detail in our next lesson. Okay, if you just keep your eyes on a destructive plate margin, which I've shown you where they are here, there's a lot around the Pacific plate. Keep your eyes on those lines there, and what you can see as that map fades away is this map is showing the distribution of volcanoes on the surface of the Earth, and you can see that the majority of volcanic activity occurs in long belts that follow the plate margins, for example around the edge of the Pacific Ocean where you've been looking. Now this ring of volcanoes around the Pacific Ocean is known as the Pacific Ring of Fire. Volcanoes are fed by hot molten rock, magma, from the mantle, and this magma rises up to the surface at different plate margins. And like I said, you're going to be learning a little bit more about the different hazards and the different types of plate margins in your next lessons. Okay, these are the key words which you're going to need to learn for this lesson. So they're really important that you know these so that when we go on, you know what we're talking about, especially when we're talking about the different types of tectonic hazards and the different types of plate margins. Okay, thanks for your attention. Well done. And there's going to be a quiz on this lesson. Good luck.